high performance liquid chromatography HPLC, that is also known as high pressure liquid chromatography. High performance liquid chromatography is a separation technique in which a liquid or properly dissolved solid sample is passed through a column at high pressure. So a solute molecule will pass through a column, and for their passing through a column, high pressure is required. So this is also known as high pressure liquid chromatography. It is used to separate, identify and quantify each component in a mixture. Basic principle of HPLC is that it separates the sample into its constituent parts based on the relative affinity of distinct molecule for the mobile phase and the stationary phase that are used in the separation. So in chromatography, the basic two terms are used, that is known as mobile phase and the stationary phase. And the solute molecule will distribute itself between mobile phase and the stationary phase based on its affinity towards these phases. The distribution of the analyte between a mobile phase, that is known as eluent, and a stationary phase, that is the packing material of a column, is the basis of HPLC separation. The molecules are retarded while passing through the stationary phase depending on the chemical structure of the analyte. If the analyte molecule has greater affinity towards the stationary phase, then its speed will be retarded. And if it has less affinity towards the stationary phase, then it will pass through. The duration of a sample that's spent on a column is determined by the unique intermolecular interaction. So there is some intermolecular interaction between the sample or the solute molecule and the column. So the duration of the sample that's spent by a solute molecule, it will depend on the type of interaction between its molecule and the packing material. As a consequence, the constituent of a sample get eluted at different time, and hence the separation is achieved. History of high performance liquid chromatography. High performance liquid chromatography is also known as high pressure liquid chromatography, and this technique is a modified column chromatographic technique. The column chromatography or simple liquid chromatographic systems were time-consuming method of separation due to the lower solvent flow rate because it was mainly dependent on the gravitational force. Now, in case of column chromatography, the solute molecule will pass through the column and there will be no application of further pressure for the passing of the solute molecule. They will pass due to the gravitational force that are acting on this molecule. So it is a time consuming method, or it is a time consuming process, because here the main component or major force involved is the gravitational force, and it will act very slowly on the column. Between 1941 and 1960, now the scientists are trying to develop some type of HPLC or some type of column technique with high efficiency. They found that the column technique could be operated with high efficiency by reducing the column packing particle size to around 150 micrometer and flowing the mobile phase at increased velocity. So between the 1941 and 1960, scientists are trying to develop the HPLC. They are reducing the particle size of a column, also increase the velocity of a mobile phase. Between 1960 to 1970, extensive scientific work has been carried out by scientists to improve liquid chromatography. So 1970 is the birthday of HPLC, because by the 1970 many developments were seen around instrumentation and hardwares of HPLC. Now the HPLC is modified in terms of various instrumentation, and the hardwares are introduced into it. By 1980, HPLC has already become the essential element of many analytical laboratories. Now it is in working condition and it becomes the essential element of many labs. Since 2006, extensive development have been made in HPLC performance and extensive improvement in automation. Scientists started using high pressure pumps, new column packing and injectors to make the basic design of an HPLC system. Now by the end of 2006, new pumps are introduced, or high pressure pumps are introduced into the HPLC column, new column packing and injectors are introduced into the new design HPLC system. Classification of HPLC technique. It is based on mode of chromatography, based on principle of separation, based on elution technique, based on scale of operation and based on type of analysis. First is the mode of chromatography, that is based on the polarity of the mobile phase and stationary phase. It is classified into two categories, that is normal phase and reverse phase. In case of normal phase, the stationary phase is polar and the mobile phase will be the non-polar. Example of polar bonding is hydrogen bonding and dipole-dipole type of interaction. In this technique, polar components of the analyte show more interaction with stationary phase than the non-polar component. Because the stationary phase is polar, so the polar solute will show more interaction with stationary phase as compared to mobile phase. And they will take the longer time to be eluted and detected. Reverse phase, the stationary phase is non-polar and the mobile phase is polar. The principle of separation is hydrophobic interaction between the component and the stationary phase. Hence, the non-polar material get retained longer than the polar components. Based on principle of separation, that is affinity chromatography, ion exchange and size exclusion chromatography, affinity or adsorption is based on the different affinity of the component towards the stationary phase. Ion exchange, and ion is used to separate the mixture of charged species. And the size exclusion, it is based on the molecular size that are separated using the gel. Third is based on elution technique, that is isocratic elution and gradient elution. Isocratic elution, the same mobile phase combination is used throughout the process of separation, which means that we are using either a single solvent or single mobile phase or a mixture of solvent as a mobile phase. But the combination ratio or the proportional ratio of these mixture of solvent should remain the same throughout the process, which means that from start of the process to the end of the process, the mobile phase ratio or proportion should remain the same, which means that the elution strength will be maintained, or the solvent polarity will be maintained throughout the process. Second is gradient elution. In this type of technique, mobile phase is constantly changed during the separation process. A combination of lower polarity or elution strength is used, followed by gradually increase the polarity or elution strength. So in this case, we will use different combination of solvents. First, we will at the start of the process, we will use low polarity solvents or mixture of solvents. Then we will increase gradually the polarity of the solvent. So in this technique or in this separation process, the mobile phase combination is changed from start to end, from lower polarity or elution strength to higher polarity or elution strength. While in case of isocratic elution, single solvent or a mixture of solvent is used throughout the process, and there will be no change in the polarity of the solvent throughout the process from start to end. While in case of gradient elution, there is change in polarity from lower polarity or elution strength to higher polarity or elution strength. Based on scale of operation, that is analytical HPLC and preparative HPLC. Analytical HPLC, as the name indicates, it is used for the component analysis, and the recovery of the sample is not done in this process. In this process, the elution or eluent or the mobile phase, it will pass towards the waste. Preparative chromatography or preparative HPLC, it is used to separate each component to get a single component. So the element is passed on a fraction collector where the individual fraction of the pure compound can be collected, and the collector sample are reused. So in this case, the mobile phase will not go towards the waste, it will go towards the fraction collector where these fractions are further used. While in case of analytical HPLC, the mobile phase or the eluent will go towards the waste. Based on type of analysis, qualitative and quantitative analysis, qualitative is used for the identification of component, detection of impurity, and to find the number of components. Quantitative is determine the quantity of individual or several components, and it is done by comparing the peak area with standard or sample. This is the HPLC instrumentation. Mobile phase reservoir are used, degasser and pumps, detectors, columns are used over here, and the readout devices. If we use the cross-sectional area of this HPLC, so here the mobile phase reservoir, from the mobile phase reservoir, the mobile phase will move towards the degasser. In degasser, the air or the gas molecules, if they are dissolved in the mobile phase, are removed. Then it will pass towards the pump. Pump will pass the mobile phase to the column using switching valves. From injector or from sample injection area, the sample are injected to the switching valve and it will move towards the column. From the column, the sample along with the mobile phase from the pump, it will pass to the column and it will move towards the detector. From the detector, it will move towards the readout device. So the main component of HPLC will include solvent reservoir in which the mobile phase is kept, pumps, sample injector, HPLC column, and finally the detector and readout device.